little bit already, but so this is going to be Introduction to Building Your Own Programming Language. My name is Jacob Mather. I'm a senior software engineer at Kickside, which is a game company in San Francisco. If you like San Francisco, we are hiring. I'm also co-organizer of the San Francisco PHP user group. I call myself also a community evangelist. I say that because the power of connecting with the community around you makes you able to be such a better developer because you get access to resources you wouldn't otherwise have. You'll bump into people in conferences that end up writing the tools that you actually use every day. And so when you're using that tool and you have a bug with it, since you've met them at the conference, you're okay just pinging you on Twitter and say, hey, dude, why is this broken? And they'll go, oh, because I haven't fixed it yet. You can send me a PR. You know, it gives you a different level of connectedness as opposed to just this magical tool that you pull off the internet. And when it breaks, you throw it away and find another one that maybe works. You got connections. And when you run into trouble, you know who to ask. If you like this talk, you can find more about what I do and me at my blog at jmather.com or follow me on Twitter at djmather. So this originally was a talk proposal for PHP Tech, and they summarily turned me down. Then they got another email from them which had the same subject line turning me down, asking me if I wanted to write an article about it. So I wrote the article about it, and if you have interest in having a hard copy version of this, this is the November issue of PHP Architect, and they allow you to buy back issues and everything. They did beautifully laying it all out. It was crazy. I spent weeks writing this thing out and handed them everything and like, I don't know how you're going to make this look good, but they managed to do it. Props to them. It's really nice, and it really helps frame it nicely. But you guys aren't here to talk about that. You guys are here to learn about how you actually build a language. So let's talk about why languages are written. At its core, a language is built because it's abstracting a problem that they don't like in another language. Like, in assembly, you have to manually manage your stack. And so C, one of the problems that C solved from assembly was stack management. You didn't have to know all the complexity of where the pointers were sitting and all that stuff. You could just write some of the code. But with just that level of abstraction, you have a lot of stuff with memory management and objects and stuff like that. You want to do more complex, rich things. So they built C++, which had the idea of objects and more complex code assemblies. But you still have the memory management problems. And so things like PHP and Java were written to abstract the details of dealing with the memory management constantly, having to allocate stack space and heap and all that stuff. And so each language becomes an abstraction of problems of the language before it. Everything's built to scratch an itch, And that's really the basis for everything. Now, when you look at how code lives, how the code magically turns from this text on your screen to this living thing, it goes like this. You have your raw source code, which you feed into Alexa, that turns your raw source code into an ordered list of tags, essentially. It's this was in the file, then this was in the file, then this was in the file. There's no context to it. It's purely just a stream of tokens that we identified in the source code. We then take that stream of tokens and we pass it to the parser. And the parser says, here's my rules for what I want things to look like. And here's my stream. And so I'm going to look through my stream and organize it by these rules. And at the end of it, what the parser outputs is called a syntax tree. It is like a nested tree version of your source code that's more logically oriented for a computer to process instead of a human. Because the source code is the human version of your software. The syntax tree is the computer version. Now, then we take that syntax tree, and for interpreted languages, we pass it into a virtual machine. The virtual machine consists of both a runtime, which is where the runtime is kind of like your brain. It's where everything's stored and lives, and it's the lifeblood of your language. And then the interpreter is what transforms that syntax tree into actions against the runtime. If you instead have something like Java where you compile bytecode, from the parser, you would go to a bytecode system, which would transcode your parsed syntax tree into a predefined, basically, library of commands that we call bytecode. And then the bytecode would be fed into the virtual machine, interpreted by the interpreter against the runtime. It's purely just adding a serialization step between the parser and the runtime. So, I don't remember what this slide is for. I'm a little bit off on this because I have the screen mirrored instead of the usual presentation view that I get, because I'm going to do live code as well. So I don't exactly remember why I put this slide there. I'm sorry. Now, let's give an example of this conversion process. Let's start with the simple 1 plus 2. We take 1 plus 2 and we put it into the lexer, and out comes our ordered list of tags. We saw the number 1, we saw a plus symbol, and then we saw the number 2. We take that and we feed that into our parser, and what we get back is a node for adding that contains 2 arguments. The arguments are values 1 and 2. You can see right here that these are very clearly 2 distinct forms of the exact same data. One is meant for us to manage, and one is meant for the computer to execute. And that is entirely what you are doing in the first part of building a programming language. It's merely data transformation. Now, if we look at how traditional compilers work, you'll see that they actually have a separate lexer and parser. In C++, or C, this would be Yak, and I can't remember the name of the other tool.
Bison.
Bison, yes, thank you. JavaScript, we've made it a bit simpler. There's a tool called JSON, which just combines the two of them. And so traditionally, you'll have a list of tokens, and you take that list of tokens, and the lexer, which would be Yak, will convert that list of tokens into a set of rules for converting source code. And that's your lexer. The lexer is the set of rules for converting the source code into tokens. And so you feed your source code into the lexer, and out comes your token stream. Now for the second phase, you have 2 pieces that you have to write. You have the grammar of your language, which explains the rules of what can come when. Same as your grammar for English. And then you have the source code objects that your grammar is going to convert your token list into. Those combined with your lexer output token stream become your parser and convert into your syntax tree. For JSON, it's simpler. We build the token list and the grammar and the node objects first step. And JSON consumes the 3 of those to build our parser and lexer combined, to which we just feed our source code and get our syntax tree. So, with the nuts and bolts out of the way, the best way that I figured to show this is just to get into the code. And what we're going to do is, while we're looking at this code and talking about it and working through it, I'm also going to implement if. Right now, the language has no concept of if. It can add things and it can print, and that is it. So, first, we have our list of tokens that our programming language has to understand. PHP is going to be the language that we're going to make a minimal implementation of, because it's the language that I probably know the best, and so I know the most specificness about it. And so I can tell you guys specifically why things are set certain ways. PHP doesn't care about white space. So these first 3 lines here you see is just throwing out white space. Anything that's not encapsulated in the string we don't care about, just throw it away. Next we have literals. These are values that on their own have enough information for us to do everything we need to do with them. That's what a literal is. It's the actual value that you want processed by the engine is wholly contained in whatever you've expressed. Like strings and numbers, those are just, that's what they are. They get wrapped inside a value holder, but that's what they are. There's nothing that needs to be done with them. They don't do anything to anything. They're just values that exist. Same for true, false, and null. They're just static values. Now we have some keywords we need to deal with. PHP has, the open PHP tag and the closed PHP tag, function and return. We don't actually even have new implemented because we don't have objects yet. I put it in there so you can see that it would be a separate thing, but we don't use that yet. After that, we want to identify our identifiers. Identifiers are sets of strings that aren't wrapped in quotes. So things like function names, variable names, constants. All of those things are going to come through as identifiers. After the identifiers, we have operators. And these are important to note because these are multiple characters. You'll see that we're just actually translating them straight through. We don't do anything to their meaning internally. Like for the PHP tag, you see that we changed the open bracket question mark PHP to open PHP. Like we gave it a very specific tag name. But the operators are fairly clear what they're doing, and they're not very awkward to type, and so we're just going to leave them alone. Lastly, we have two final pieces that you're always going to want, no matter what kind of language you're implementing, and that's going to be your catch-all rule. For any other character, just translate it directly. Just don't touch it, don't do anything with it, just translate it directly. And then end of file, transform into the end of file like tag so that we can clearly see it. Now, we want to add if. So we're going to add an if here. And give it a way to transform that so that we have a tag to address it. And that's all we have to do on that part for implementing if. Now, let's take a look at the nodes. The nodes are the objects that our tags are going to be converted into once they hit the parser. And so we have a generic block node. And the block node is for a collection of executable statements. Statements are anything that doesn't return a value. We'll get into that a little bit later on the nuance of it. So we build a block node, and we add in the ability to pass in a predefined set of nodes that we want to set to it. I'm going to go ahead and actually make this a little bit more flexible. We now have a default. If we don't pass in nodes, it'll just assign it to a default array. We add push so that we can very easily just put more executable statements into a block. And that's all we need for the block node. Number node just stores a value, same as string node. True, false, and null are a little bit different. True, false, and null always just have their value. There's just one of these that's going to be created. Because you don't need to have separate instances of true, false, and null. They're never going to actually be different things. So we're just going to have them as basically like stacks. You'll see that when we get to the runtime. Now, we need some for our specific actions. Like part of a programming language is setting a variable to something. And so we have a set variable node, which takes the name of the variable we want to set and the value that we want to set it to. We have the get variable node, which takes the name that we want to get. We have a call node. This is the abstract for anything that's going to execute a function. Whenever anything in your code is executing a function, you'll transform it to a call node. And the call node takes the name of the thing that you're calling and the arguments that you're passing to it. If we were doing this, if we were re-implementing JavaScript, our call node would also have a scope that would be passed into it, because JavaScript, the scope is much more floating. Function node takes the name of the function the parameters required for the function, and the body content of the function, which is going to be another block node. Return just stores potentially a value to return. Then we have add, track, subtract, add, subtract, multiply, and divide. All of these could probably be collapsed a little bit more if we wanted to refactor a little bit nicer. But this is about being explicit, because I want you guys to very clearly see the delineation between the pieces. So I didn't try to get too fancy. There's a lot of repetition in here just to make sure you guys can clearly see where the pieces are. We also have concat, because PHP has its nice little dot between two strings to just concatenate them, and it felt like it was appropriate to add in. So there's our existing nodes, and now we will add if node equals a function. Now ifs, if you look at their structure, we're going to ignore the else. We are just going to implement if. So an if has two parts. It has the expression, that is the condition of whether or not you pass. And then it has the body of the if that executes if that expression returns true. And so we will do if node expression body. This expression, this body, not bossy. All right, and there's our node for our if. So now we get to the really...
One question.
Sure.
So that file you were editing, where does that come into play in that initial diagram you showed?
So this file is, here we go. That file is this part. Here, I'll make this bigger. And now I don't have a mouse. So the file we were just in is the node objects. This is the pieces of actual source code that will run inside your engine that you're converting these tags to. Does that make sense? Okay. So now that we have our nodes set, let's take a look at the grammar. And the grammar is really like the meat and potatoes hard part that'll end up hurting your brain. Because the grammar relies on you thinking recursively. And so you have to have a lot of practice thinking recursively to really do a lot of intense work in the grammar. But if you start from something that's already working, you can probably convince it to do what you want it to do, just with a little bit of hacking. So the grammar consists of three main parts. The first part is a little bit of JavaScript code. Our JavaScript code pulls in our nodes so that we can tell our grammar how to convert the tags into the nodes. The second part describes like the meta information about your grammar. It says, the left-right non-associative says, when you interpret these things, look at them this particular way. And so this is how you control order of operations with plus, minus, divide, what triggers when. It's how it resolves a line of code that would otherwise behave in an unspecified way. Because if you had A plus B minus C, and you didn't have rules about how it should interpret those, it would be free to do it however it wants. But since the plus symbol is less associative, it means that the plus will, I'm trying to figure out how to explain. I had a good explanation for this in my head, but it ran away. Of course, now that I'm standing up in front of everybody, it's just gone. It controls when something triggers. So if the plus sign was less associative and came before the minus sign, then plus would be handled before minus in the which do we do first. And left associative says you need to resolve what this does on the left-hand side first, I think. I'll have to double check that. But I believe it's you have to resolve what's on the left-hand side first before you can process this piece. It's all the parentheses you don't see when you write that line. This is the rules of how to put those parentheses in so it can figure it out. Lastly, we tell it the start tag says this is the very first thing you need to match when you start trying to interpret the source code. And so we're going to start at program. The last part of this, the last section of the grammar, is your actual rules for what can contain what. So I think that this one usually is actually easier to start from the bottom. To start with the smaller independent pieces and work our way up. So we'll look at return. Return in PHP can either just be a return statement or it can be a return statement with an expression. An expression is any set of code that returns a value. So we have return. We're allowed to either do it with no expression, in which case we just generate a new return node, or we generate it with an expression, so we'll make a new return node and pass the expression into it. The double dollar sign is kind of a convention of grammar definitions. I'm not sure of the actual origin of it, but most of the grammar definitions I've seen have just used the double dollar sign for the return of a token match. So after return, we have parameters. In PHP, a parameter is a variable or a set of variables. And so we define a variable as a dollar sign and an identifier. And then we can stack them. We can stack a variable into a set of parameters if we say parameters are either an individual variable or anything we've turned into a parameter already followed by a comma and another individual variable. See, we're back to recursive thinking. And so it takes a little bit of work to get used to. And so if we define a function is going to be a function tag. Oh, there's a question?
Can you explain again how the dollar sign and the uppercase identifier work together there?
Sure.
Are those a single thing or are they separate?
So each one of these is either going to be a piece that we've already processed by the grammar, such as parameters, or they're going to be the individual tag names that have come across from our tag list. And so the dollar sign identifier means, there's a space there, but it actually just means that what we want to look for is variable. This rule, this dollar sign identifier, will match this.
Okay.
It'll make more sense as we go on. It's really like an onion. You have to get to the center for it to all really make sense. And so bear with me. I know it's a little bit confusing. I'll try and make sure we're wrapped up and everybody feels comfortable with it before we get done. Okay. Functions are a function tag, an identifier. Then we have the parameter, the parentheses. And we have any number of parameters in the middle of it. And then it has any number of statements enclosed by curly brackets. And so we translate that, and we say, when we see this set, we will return a new function node, and we pass the identifier, the parameters, and the statements. Each number here, the $1, $3, corresponds to the match number. And so this is $1, this is $2, this is $3, and so on. So as we go up, let's define some operators. Operators are any expression with the operator in the middle, and then the expression on the other side. Any of those will be valid operators for anywhere else in our grammar. And so now if we do arguments we do just like the parameters, except we don't need to do them quite the same way, because they're just expressions. Parameters for a function need to have different, more complex rules, because you can define defaults, you can define types in the parameters of a function definition. But you'll never have that, say, in a function call. The function call will just have the list of actual variables. And so we've created now something we call arguments, which is a list of variables. And an argument is either going to be an expression, or any number of given arguments followed by a comma and another expression. So a call, then, would be any arbitrary identifier that has no other matching context, paired with parentheses and arguments. See, we break down a programming language to its very basic pieces, and then we build it back up. Now see, here we have a variable. And in PHP, if you assign a variable, that it actually treats it as an expression. And so even the assignment returns the value that you assigned it to. And so in the code, in our grammar, we can treat referencing a variable directly and assigning a variable the exact same way, as far as like what it means grammatically. But you'll see over here that when we just reference a variable, we use a get variable node. But when we set, we use a set variable node. So the actual mechanics of what will happen when we execute these things will be different, even though contextually the result for anything using these will be the same. Now we have our literals. Let's group them all together, just so we know that we already have them handled. And number nodes, we'll just force the number to parse to int, because I'm not going to actually support floats yet. No decimals, no floats. We're just going to support ints for right now. Remember, minimal implementation. Get the basics right. Get a feel for it. Strings, we actually have to do a little bit of trickery, because the strings come through with the quotes on the ends. So we got to take the quotes off the ends when we turn it into a string node. PHP actually treats double quoted strings differently than single quoted strings, and I've ignored that difference for now, just because it's much easier to deal with. True, false, null, we return true, false, and null nodes for it. Now, let's talk about expressions. What are expressions? Expressions are any sets of code that return a value. So expressions are made up of any literal values, any variables, any calls, any operators, and any expressions encased in other parentheses, so that we can enclose our expressions logically to control their own flow. Now the difference between expressions and statements are statements don't return values. Statements just execute. Like if is a statement. So since if is a statement, we're going to go in and we'll say, first we have to actually define our if. So we're close enough now, so we will do if statement. And that will be an if followed by a parenthesis, and then it will be an expression followed by another parenthesis, followed by an open block, which will then contain any given number of statements, and a close block. And this will translate into a new nodes if block with numbers 3, 1, 2, 3, 4, 5, 6, and number 6 passed through. And that is our if statement. That is the definition of an if, right? This is how it looks. This is how it looks in the code if you remove all the spaces and remove all the details. That's all you need for an if. And so now we need to also tell it that an if statement is, in fact, a valid thing. And you don't actually have to list what to do with something if the definition for it returns it in the way you need. So you see here, if statement doesn't actually define anything to do with it, because when it comes out of the if statement block, it's already the if block. It's already everything we need it to be. However, if we look at the expression, expressions have to be terminated by semicolon. Because that's how you know that's the end of the expression, right? Statements sometimes don't. Like ifs don't have semicolons at the end. And that's in JavaScript, where sometimes they do. So we have to have that distinction and keep that there. Returns are statements, but they need the semicolon at the end too, so that we know how to delineate it. So now we'll wrap statements up. So statements is any single statement which will create a new block node passing that statement in, or any existing statements object followed by any statement, at which point we will just push that into the first block that we made. Finally, at the top level, we have programming. PHP programs, they start with the open PHP tag, and then they're followed by any given number of statements until they reach either an end of file or a closed PHP tag. Now, there's a little bit more nuance in it because in PHP, files don't actually have to start with a PHP tag. They can start with any sort of text content, and then you trigger the PHP engine later, and that was a detail I didn't want to get into. We can actually look at the, up here we have the language definition for PHP. And that's what I referenced to build the association list for the processing. And I actually looked through it. A lot of this is pretty close to how they actually define it. I do a lot of simpler stuff because it's nowhere near as complex as what I'm doing. But it's pretty close to what they're doing. And so now that we have the if statement in, and we've talked about the grammar, it's time to look at the runtime. This is where your code will live. This is where it comes to life. And the very first thing you want to do in the runtime is decide how you encapsulate the value. Instead of passing around nodes or anything like that, we're going to actually give our values a place to live. Because that allows us to add things in later, like reference counting, to track for memory usage, and all that fun stuff. We don't have that now. We don't need it now. This is just basic implementation. But we give ourselves the tools to add things later and make it not painful. After we have a place to store our variables, we're going to define scope. Scope in PHP is really simple for the most part. They have a little bit of weirdness with having super globals that you can sometimes access, but we're going to ignore those for now because that just makes it more complicated. We don't need it complicated right now. We're dealing with hard enough stuff already. So scope is simply going to be a very fancy way to deal with a hash map. That's it. That's all we're going to do right now. You can set a variable. You can see if it has it. There's no complexity to it. You can see right here. And I've even built it so that if you grab something that isn't there, it'll just return null. We don't break anything. We're just trying to make it work. And so sometimes in other languages, like in JavaScript, scope actually has an inheritance chain because JavaScript has its prototypical inheritance model. So if you implement scope in JavaScript, you actually have to allow to pass a parent scope into a new scope. So it can go back up the chain and try and find a variable. And there's trickery that you have to do when you're setting variables, because if you are in an inheritance scope and you set a variable that belongs to the parent, you actually need to set that variable in the parent scope. But PHP doesn't have that weirdness. So we keep it simple. Now we need to define a function inside the runtime. This is different than a function inside the lexical parsing system, because the function inside there is the definition of the function. It's the structure of what you want to happen. Over here is our operating context of the function. This provides the tools for us to reasonably manage how a function runs. We'll get into it right down here. But you see, for instantiating a function, you pass the name, parameters, and body. And so it's kind of confusing because it looks exactly like that function that we built. But over here, down at call, you start to see why we do this a little bit differently. Call is going to be our language's internal way of executing a function. And in order to call a function, we have to have scope and arguments to pass to it. And so when we execute a function, we create a new scope because in PHP, every function has its own independent scope. And then we assign the variables that we've been passed to execute into this function into the scope that we've created for that function. So that your scope for the function is really just the variables that you called the function with. And then finally, to return the output of the function, we will call eval. And eval we'll get into in the last part when we're talking about the interpreter. But eval, called with the scope that we want to evaluate the code within, executes the function. We'll create our primitives within our runtime. And we're going to actually just do them exports, true exports, false exports, null. And anytime we reference them within the system, we'll reference them just as the true, false, and null. We'll never instantiate more new true, false, or nulls. Because we only ever need the ones. They're static values. And so now this is the heart of it. We instantiate our root scope. This is the global scope for the entire PHP system. And it also tracks functions in its separate system for globally defined functions. And so I just use scope to hold the functions as well. It works. It's nice and reusable. And just to provide ourselves a little bit of glue, I'm going to give us a way to communicate back with ourselves. And we've defined a print method. And so you can see we call the function scope and we say set. So we're saying store this. And we're going to call it print. And so whenever this is referenced, you're going to return a PHP function whose name is print, and the signature of the method expects one variable named content. And when we eval this object, what it should do is get the value for content out of the scope. And we'll do a little bit of extra processing. We'll replace the escaped new lines with actual new lines, because we like to be able to make things look a little bit nicer. And then we will, on the JavaScript level, output that information to the screen. This is the first kind of like real, actual integrated taste of what's going on under the hood. Now for the last part, we have the interpreter. For the interpreter, we pull in the nodes in the runtime, because we need these two pieces. And on each of the nodes, we're going to call the eval method to teach the software how to execute itself. In other setups, you may break out each node into its own file, and then define both the structure and the eval in that one file for that one node. But it's easier to teach this in systems. And so it's broken out this way in systems instead of in isolated pieces. So we pull up our information that we have, and because JavaScript is nice, we're just going to change our objects in flight. And so for the block node, for eval, we're going to wrap it in a try, because the mechanic for how a return executes is triggering an exception. It's just the easiest way to implement it, and that's how we've done it for right now. And so, wrapped in a try block, for each of the nodes that we've stored, we're going to run eval with our scope. That's how you execute any given block of code. You just eval it, giving the scope. So the scope stays the same, and the method you're executing will change the scope appropriately. As long as it runs through, if it catches a return, it will return that value. Otherwise, it will return null. We've encapsulated a return object because nothing else really needs to know about the mechanics of how that actually runs. So for true node, false node, null node, their eval functions simply return their runtime equivalent status. Eval is, the best way to think about it is eval is where your two languages collide. Like if you're going to run into actual problems with how your system is running, most likely it's going to be in the interpreter. Because most likely what you've done is just gotten your two languages confused, and you've returned one of your development level languages into the program level context. Or you're dealing with the program level language in the development level context, and you just like mix something up. So, string nodes, eval with scope, just returns a new wrapped value. That's what it does. It wraps it in the PHP's runtime value and passes it back through. Same for number node, it's just a value, it's just a literal, it's just a store. Get variable node, when we evaluate it, we'll look inside the scope and return you what we've stored for that name. Set will go inside the scope and set the value to whatever the valued node we set evaluates to. So in order to set something, we have to, and this might actually be not correct, but the code works. Like my brain is having, I've messed with this lots, and my brain is having trouble wrapping around this. So, in order to set a value into the scope, we have to evaluate what that value is first. And so we evaluate the value node that the set was passed. And we set that into the scope of the current context that we're working. Now, a function node, when evaluated, returns a runtime PHP function that passes its name, its parameters, and its body in. It then sets the function by its name into the runtime's function list. And it returns that function object. Call will pull our function out of the function list. It will then evaluate all of our arguments to collapse them down to the actual values that you're supposed to be. And then it will pass it to the function's own internal call method, passing its scope and arguments. Finally, down at the bottom, we have our operators: add, subtract, multiply, divide, concatenate. You'll see that these work pretty much the same way as the rest of the system we were looking at. It evaluates the individual nodes that we gathered during the interpreting, the parsing process. And then once it's evaluated those, it performs the action required. And then returns the PHP value that we need. Now, I have to double check. Okay, I don't need anything in the runtime. But over here, we need to go nodes.ifNode.prototype eval. So now, this node has an expression. So we'll say the expression is this expression dot eval scope. So now we know the value of our expression.
You know that's an expression.
But he spelled it wrong in the other places as well.
Oh, really?
So, sorry.
No worries. And then we'll say if expression dot value equals I think this is right. Runtime true.
Very brave.
Then we will call this body eval scope. So if the expression evaluates to true, we will run the body, and ifs don't return anything, right? They're statements, not expressions. So we don't need to return anything in our method. So now, let's flip over to the command line. And this originally started as a project by another guy who wrote a small implementation of JavaScript. And so I kind of adopted it, and I didn't change its tool chain at all, but I've moved everything else. So if we run make, ooh, look, we broke something. That's always fun. All right, could not parse the JSON grammar. So let's look at our grammar. I bet I know what I did. I forgot a semicolon. Hey, compiled. We'll run our tests. We haven't written any tests for the ifs yet, but everything else passes. He actually had a really cool idea for how to smoke test it. And what he did is he made a directory that just contained code samples. So we have hello world, a couple math ones, and what it does is it runs the file through the PHP interpreter and runs the file through our interpreter and compares the output. If the output's the same, we're good.
That's right, yeah.
I thought that was pretty genius. And so now we're going to do if.php. And we'll say PHP if 1 equals 2, print hi, and php.js samples if. Oh, something's broken. It doesn't know how to evaluate anything. We haven't implemented equals. Okay, so tokens. We have the equal token. Good. Grammar. Down here, we don't have anything in grammar. But it's really, what is equals? I'm trying to think. Equals, we'll do it as an expression. That should be fine. Expression. And then we'll say equals node. 1, 2, 3. And so now we go back to our nodes. Exports equal. I'm going to try and do this real quick because I know we're kind of getting into lunch and.
Just food trucks.
Yeah, that was interesting.
Argument 2.
So we have our nodes.
Argument 2 instead of argument.
Oh, yeah, that might work. All right, so we have our equals. Now we need to go to our interpreter. We'll do nodes equals node prototype eval function scope. So there's our equals. It's just an expression. We pass in 2 arguments, and if they're the same, we return the runtime true. If they're not, we return the runtime false. And so now let's see what happens. That's still broken. Got. Okay, I forgot to tell it that that's allowed to be an expression somewhere. Back to the grammar. Why are you not happy?
You gotta
Here's the build it.
Expression was spelled differently.
Here's the read.
Oh, you're right, thank you. Details. Rebuilt. All right, undefined is not a function.
Nodes if block. It was the if.
Changed the if blocks now.
Which one?
Nodes if block.
Yeah, so
Ah, you're right. Okay, if block parser, blah, blah.
Line 102 on parser.js.
Here's the if. So here's somewhere. If. Nodes, if block. Did I break my nodes?
If
If it
Oh.
was in the parser, like if block is not defined as a function.
Yeah, we did it's called if node.
That
you
may
gotta
be.
rebuild it.
All right. We got no output.
No.
Guess what? That means it technically worked. It didn't blow up.
Now
Well, let's make it.
If 1 equals 1.
Okay. We got some more weirdness. All right. So let's test the interpreter. Because we have our test suite over here. So we'll just say, I'm just going to do it top level over here. We'll just do it works. Nodes equal parser.parse. If 1 equals 1, print assert. Okay. Oh, we'll do this. Okay. That'll be an easier way to test it. So assert equals node eval runtime group scope value is 1. Now let's see what we're getting. So it says has no method equals.
Yeah, he typed equals instead
Ah.
of equal, like the
Ah.
There we go. No, not equals 1.
We got no.
All right. So
I
eval.
start console locking.
Yeah.
Or hard open.
So you see, implementing this stuff can get a little bit tricky. Fortunately, I think the problem is actually in my runtime, and so I'm going to cheat. Or interpreter, rather. Let's look at how I implemented it down here. Let's see here, interpreter. All right. Nope, this is doing it correctly. And so I bet it's the if node. What is our if node doing?
You're not returning on the inside of the if, maybe?
Let's see. If node says this equals true. Oh. That was a problem. I was inspecting it too deeply. The response of an eval is going to be the PHP level value. And the
Not
dot
your
value
internal, yeah.
inside a response is going to be the language value. See, again, you have to keep track of where you are in the code. And so now, if we close this and we rerun our test, we get a different error. Eval method of undefined. Oh, because I changed the names of things. So nodes, if node, expression and body. Interpreter, if node, expression and body. This is R1 and R2.
You do have expressions spelled in multiple places.
Change the other one.
Which one? Where?
In your if node, where is it at?
It's in
The
the
other
other
file,
file.
one of the other files, there's.
Parser.
You spelled expression with one N. Yeah.
Yeah, that one's got a 1S too.
Both the
Both.
parameter and the data number are one N.
All right, I'm going to leave this expression and I'll fix it over here. There. That should hopefully be null not equals 1. What am I missing? Something's missing somewhere.
On console log.
Ah,
That's how I did it. Not really visually, but it's effective.
Oh, what's call stack say?
Yeah.
let's see. It's really like dense to try and work through.
Thanks to all this in the runner.
Equals 1. Test says right, so we have to look at the dot value, right? What happens if we do this? Value null equals 1. So why is it returning value null? So parse the if, oh, the
Put it inside of a function, maybe, your PHP string. There is no return from the if statement.
see our if node. That's exactly what we have over there. What about
PHP statements. Yeah. Does the PHP program itself have a return value?
I'm sorry?
Does the PHP program itself have a return value?
The if statement doesn't have a return value, right? It's just a string.
Oh, that might be, but
So put it inside of a function and return from the function.
but these are working.
But they actually have a return. I don't know.
So what if we take off the if? Let's eliminate. Let's figure out what's broken. Okay. Okay, so we do dot value because we're actually looking at the JavaScript value, not the PHP one at this point. Okay, so now it passes. So we have a problem with our interpreter of if.
Because it doesn't return,
Because it's a statement. Then.
your other ones actually return value.
Yeah, okay. So,
Because an if is a statement as opposed to an expression.
yeah, we still have to return because we may possibly get a return executed inside the block.
So if you're saying if you wrapped it in a function and then put the if else inside the function.
Right, let's see. Go back to the interpreter. So now I do if 1 equals 1. No, we're still getting null.
Can you wrap that if statement itself inside a function so that the upper level thing is a function? That would have return value.
I'm actually trying to figure out what I did differently between that and this right here. We'll just look at this real quick.
Is your code up on GitHub? Is that
Yes.
run?
Code is up on GitHub.
Yeah, we'll find it.
If isn't implemented, but I'll figure out, fix it.
I actually pull request.
There is a branch that has if implemented, but it was before I cleaned up the code for this talk. And so it's there, and you can see it work. But I'll get it mapped in for this version of the code. It will work. It does work. Eventually.
One of the most
But you can
impressive-
see this is hard. This is hard stuff.
And the most impressive thing is you have the rest of the audience followed you the whole way and they were helping debug it, so everyone got
Right.
it.
So you guys are starting to get it.
Yes, that was the very clear indicator, like, hey, the audience got it.
And now you guys have the resources to